All right, so now that we know the difference between inequalities and equations, we're going to talk about how to solve the inequality. Like I mentioned in the last video, you can't just find a letter x that works, a value for x that works, and think that that is your solution, okay? Because there are infinitely many solutions. So when we solve inequalities, we are solving it the same way like we do an equation. We look at what's going on and we find that inverse operation. Okay, so when I look at this, I like to kind of divide it. And I kind of think, okay, well, this side is my algebraic expression. This side is my numerical value. I want x all alone. And right now I got a times 4. So to undo that, I'm going to divide by 4. But it's an equation. It's like an equation, although it's an inequality, right? It's supposed to be balanced. If I divide this side by 4, I need to divide this side by 4 as well. And that leaves me with x, and my symbol was greater than, so it is still greater than. X is greater than 10 fourths. Okay, now I can simplify that with my getting rid of my common like terms. I am recording, Reen. And so x is going to be greater than, and I divide both sides, both numerator and denominator, and I divide it by 2, and that's how I get x is equal to 5 fourths. 5 halves. Okay, divide by 2. Or people can write this too. You don't have to write both, but it's x is greater than 2.5. All right, so that is how we do our inverse operations. Same thing with our inequalities. Okay, so if we look at this one here, okay, this same thing. I think, okay, here's my x, what's going on? Okay, and then this one is less than or equal to. So inverse of minus 8 is plus 8. So I plus 8 to both sides, and that's how I get x all alone. And it's less than or equal to, and I have negative 12 plus 8. Those are different signs. Different signs subtract big abs minus small abs, and that gives me 4. Then I keep the sign of the larger guy, and it's going to be negative. Okay, and that is how we solve. Okay, now I'm going to clone this page, and I'm going to show you how to graph. Well, I will not clone it. I already had it set up. Okay, so I already showed you how we got to this. X is greater than 2.5. And then this one, I actually added it in. It's actually less than or equal to. So I added that in on the other problem. All right, so this is our solution, but it's not the only solution, right? It is our it's what I call our barrier. It's our middleman. It's our tipping point. Everything on one side is a solution and everything on the other side is not. And that's the trick with inequalities, is finding that barrier, that middle guy. And to do that, you use your inverse operations. Okay, so to graph it, because this one is greater than, think about it. If I plugged in 2.5 for x, is 2.5 greater than 2.5? And the answer is no, it's not greater than, it's the same. They're equal to. All right, so that means 2.5 is not a solution because it doesn't make the sentence true. 2.5 is not greater than 2.5. Okay, so then you're like, okay, well then how do I graph that? Well, let's go up to 3 then. Let's start at 3 because 3 is greater than 2.5. Okay, but so is 2.500001, right? All the way right here. It's kind of hard to see. Anything little points all right after 2.5 will be a solution, but not 2.5. Okay, so the way we graph that is we draw open circle. Because typically when we graph, if we put a point in a spot, that means that is a solution. Okay, a line in our graph is made up of infinite little points that are all solutions. Okay, so when we graph this and we put an open circle on 2.5, that communicates to everybody. It's kind of universal language that 2.5 is the barrier. 2.5 is that middleman, but it's not part of the solution. Okay, and so we circle it, and we know 2 is not a solution, so we're not going to go towards 2. 3 is a solution, so that is the direction that our graph is going to go. This graph represents all of those infinite number of solutions. It represents 2.5555, 2.59, it represents 3, it represents 10, this represents 200, it represents everything greater than 2.5. Okay, so that's what this graph is, and that's what it means. Okay, if we look at this problem, we had x is greater or equal to -4. Because it has that equal sign, then if I put in -4 for x, is -4 less than or equal to -4? And the answer is, well, yeah, it is. It is less than or equal to because it is equal to. All right. So we found out that -4 is part of the solution. And so to mark that, we draw a dot on the grid. Okay. It's not an open circle. It's actually a dot. Remember, because a dot signifies that it is a solution. So we draw a dot. And now we are saying it's supposed to be less than 4. So is -3 less than 4? Or is -5 less than 4? And the answer is -5 is less than 4. So that's where we're headed. We gotta go towards the -5. Okay, and then this graph represents all of those infinite numbers that are less than -4. Okay, now here's a little trick I like to show. If your variable is on the left side in the inequality, the symbol, the inequality symbol, will point the direction of your graph. Okay, so like this one was less than, right? It's less than. That inequality symbol points the direction of my graph. Okay, and that works when your variable is on the left. If your variable is on the right, you have to flip it and rewrite it. But yes, so it points the direction of your graph. But like I said, the other way to do it is you think, is 2 less than, or sorry, is 2 greater than 2.5? Nope, so you don't want to go towards 2. Is 3 greater than? Yep, so that we want to go towards the 3. Okay, so that those are 2 ways that you can graph it. Okay, alrighty.